we're looking at 6.4 today, Pre-Calculus 20. It's McGraw-Hill Ryerson Pre-Calculus 11 textbook. We're working out of, and we're looking at page, everyone quiet down please, page 341. So please join with me in your textbook, page 341. Okay. Page 341, thank you. Now, this is important to study, guys, because as you move through math, remember this course is called pre-calculus, right? So guess what we're preparing you for in these courses here? Calculus, okay? Now, not only calculus, but any upper level math, but this is specifically pre-calculus kind of stream to help you have a great foundation for calculus, both in high school and in university. So if you do anything math science related, you're going to need calculus, and if you follow through the calculus here with me in high school, you're going to be in great shape to do very well in your first year university calculus class, whether you need it or not, to tell you the truth. If you take calculus in high school, you'll be able to get a very good mark in first year university calculus because it's a lot of the same stuff, to tell you the truth. A lot of the same stuff. So it'll be like you're doing this hard stuff, but you're doing it twice. You've already done it. You're doing a lot of it twice. So the second time. So if you need a class that you need a super great mark in, you can take calculus in first year university even if you don't need to. Because honestly, if you've done it in high school, you're going to be set up to have a class that you could potentially get a very good mark in university. So, having said that, what are the applications of this? Why are we learning this? In calculus, there's a lot of work that we have to do with adding and subtracting and solving equations. And a lot of those equations include rationals. And so we've been learning all throughout this chapter how to simplify rational expressions, how to add, subtract, multiply, and divide them. So now what we're going to do is we're going to put the last piece of the puzzle together here in 6.4. This is the last section in the chapter, and we're going to learn how to solve rational equations. Okay? So you can read through the little story here in the textbook and that sort of thing. But what I want to do is just highlight sort of what a rational equation is. That would be a good place to start here as well. So, a rational equation, very simply, it's an equation containing at least one rational expression. So it's an equation, obviously, containing at least one rational expression. So here are some examples. X equals x minus 3 over x plus 1. That's a rational equation. X over 4 minus 7 over x equals 3. It's another example of a rational equation. So when we're solving these, okay, so remember, solving means find x. I'm still running into some of you, to be honest with you, that on tests and quizzes, when it says solve this equation, you're just simplifying things, and you're not actually giving me a value for x or an expression for x or anything for x. You have to give me x equals. That's the answer I'm looking for when we say solve. Okay, solve. Find the missing value, or find the expression for the variable or whatever it is. Okay, so solve means find the answer or the number in most cases for the variable. So if I ask you to solve something like this right here, I'm asking you what is x that goes here and here that completes this equation, that makes this equation true. The left side equals the right side. So when it's easy and simple, you might be able to say, hey, I could probably figure this out here just by trial and error. For easy ones, you probably could, but there's a lot of things when we learn math, there's a lot of easy examples that we start off with that you could say, hey, I can solve this a different way. I don't have to learn this thing he's teaching me. Well, the point is to learn something new with an easy question so that you can see that it works and that it's not a difficult question, that you don't get bogged down in a whole page of work. So again, when you're learning math, the teacher is going to give you simple questions at the beginning, and you need to try out this new concept on it. Okay? So yeah, you could probably do trial and error here and find out the value for x. Pick, what could you pick? 12, 14, you could pick something, I don't know. What would work in there? Well, you could trial and error and find it out. But I'm going to show you today how we're going to use what we've learned to actually solve for this. So why don't we try it? I guess I hadn't really planned for this, but why don't we try this one and see what we can do to solve this. So I'm just going to rewrite that down here. So x over 4 minus 7 over x equals 3. So there's two different ways of looking at this, okay? Two different ways of looking at this. And one of those ways is to say, let's get a common denominator for all the terms in the equation. And we certainly have done that. Last section we did that, right? We talked about common denominators. You can do that. I am going to suggest, I'm going to show you the way that I would do it, because I'm a little bit lazy. Maybe like some of you, I'm not sure. But this way saves a little bit of time, and the concept is really the same. So let me just explain. If you have, okay, this is a different example, but what if you had 2 over 3 plus 1 over 3 equals x over 3? If you have common denominators in everything, right, and it's an equation, as soon as you do this, I'm going to multiply by 3. I'm going to multiply everything. It turns into, watch this, it turns into this. 2 plus 1 equals x. You see that? So we're going to use that fact, and instead of finding common denominators and then eliminating the common denominators, which is kind of what we did here, we're just going to go straight to multiplying a number. We're going to look at the common denominators, examine them, and then we're going to go straight to multiplying. It's almost the exact same thing, but I'll show you some examples, and then I'll point things out in the book, and I think they do it getting the common denominator way. But like I say, you can save a few steps, and it's not that tough to figure out. So it's a bad color maybe. I'm going to change the color. My answers are going to be in black here. So let's say this. So if we're looking at an equation with denominators, we usually try to get rid of denominators when working with fractions, right? So in an equation, you can multiply both sides of an equation by any number, any expression, anything. As long as you do both sides, then it doesn't change the equation. So we're going to use that. And what I'm going to do is I'm going to say this. Okay, look at the denominators here. There's 4 and x. If I multiplied all of these terms by 4, and I'm going to do this one step at a time. Once you get good at this, you won't have to do it one step at a time. You'll be able to do a couple steps at one time. But if I multiplied everything by 4, I hope you see that when I multiply this first term by 4, I end up with x. Because you see how there's a 4 on the top and a 4 on the bottom? That cancels each other out. See that? This one is going to be 4 times 7 over x. This one's going to be 3 times 4. Okay. So notice that by multiplying everything by 4, that's one of the factors that show up in the denominator. I get rid of a denominator in one of those terms. Now, what do I have to multiply this new equation by to get rid of this denominator? I multiply everything by x is absolutely correct. So now what happens? Well, when I multiply this by x, that's x squared. When I multiply this by x, that's x times this over x. So those x's cancel out. So I just still have my 4 times 7 there. And this is going to be 3 times 4 times x. So now this is we've got no denominators now. Great. Great. Now we can solve this just like we did when we were little itty babies. And this is going to be great. This is going to be minus 28. This is going to be minus 12x when I bring that 12x over from the other side. Equals 0. Let's get this in the right order. That makes a little more sense for us. Now we see we have a quadratic, and this quadratic can be solved using zero product principle, can be solved using quadratic equation, however you want. You've got all the tools in your tool belt to solve this, no problem. So let's see, can we make this into two binomials here? What are two numbers that multiply to 28 and get to 12? Have a difference of 12. Sorry? 14 and 2 is exactly right. So how can we do plus or minus 14? Okay, so it looks like negative 14 and positive 2. That's going to multiply to negative 28 and add up to negative 12. So guess what? Our x can equal, looks like 14 and negative 2. Okay, 14, negative 2. Now, the only other thing we need to do is double check. We're going to check to see if each of these work, but you want to double check to see if we have any restrictions in the original question. So here I know that x cannot equal what, according to this? Well, there's no x value in the denominator there, but there is one here. So x cannot equal what in this question? 0. Good, you guys are great. You're getting it. So this is not 0, this is not 0, so there's a good chance that both of these would work. Well, let's check them. And you could check them just by just mental check if you want, which I might do. So let's see, 14 over 4, I'll show this, I guess, minus 7 over 14 equals 3. Let's see, 14 over 4, is this right here? 14 over 4 is what? That's 7 over 2 minus 1 over 2 equals 3. That's 3.5 minus 0.5 equals 3. Oh, that looks good. And what about negative 2? See, this would have been a little bit tough to get these answers from trial and error, right? So let's do a different color here. What about negative 2? So negative 2 over 4 minus 7 over negative 2 equals 3. That's negative 1/2 plus 3.5. So that's equal to 3, and that is true. I'll just stop there. So these are our two answers. Take a deep breath and or wake up if you're sleeping right now. Thank you. Any questions? No questions? This is good? Understandable anyways? I don't know about if it's good. You guys can decide if it's good or not. Okay, let's take a look. What other kind of questions might we have here? Okay. All right, well here's one right here. Let's do one like this. Let's do this first example. Okay? Because like I say, this is a bit of an extension from what you've been doing, but it's not much of a stretch at all, I wouldn't say. Okay. So here's a question. Example number 1 from your textbook. And example number 1 is found on page 342. Okay, and I guess, yeah, you know what? They're doing it the same way that I'm suggesting. So they're not getting common denominators first. They are just multiplying by all of the factors that are in the denominators. So that's great. But we need to know what factors are in there. So let's do this. This is z minus 2. Shh, girls. This is z plus 2. And over here, this is 6 times z plus 2. And this is 1 over z minus 2. Wow, that's pretty messy. Anyways, okay, so we do not have to get common denominators, but what we can do is multiply, okay? Multiply by the denominators, the factors in the denominators that we see. So I'm going to multiply everything by z minus 2 and z plus 2. And what's the other factor that shows up? 6. Okay? So again, multiply by this one, and by this one. You do not have to multiply by them a number of times, just one each. Okay? All right, so watch carefully. I'm not going to write out every single little step, but I want you to watch carefully. So when I multiply this thing by this, right here, I don't know if you can see that. So when I multiply these two, look what happens. The z minus 2 cancels with the z minus 2. The z plus 2 cancels with the z plus 2. Everyone seeing that? And what am I left with? I'm left with 2 times 6. So you can do all of this kind of at once, and this becomes 12. That's it. All right? All right. So let's take a look now at this times what we've got up here. So I've got the 6 is going to cancel with the 6, or divide with the 6. And the z plus 2 with the z plus 2. So what do I have left? I have 10 times z minus 2. Okay? So finally, let's multiply this one here by this. So the z minus 2 is going to go with the z minus 2, and that's it. So I've got 1 times z plus 2 times 6. Okay? Now, if that totally blew you out of the water, if that's too difficult to see, please refer to page 343 in the text. Okay? And I will just maybe zoom over there just right now real quick here. Okay, so this looks like right here. Yeah. So you see how they've written the same thing, okay? And they've written it out separately right here, in this line right here, okay? That line right there. That's what they've done. So this times the first term plus this, the same thing, times the second term, and this times the other term on the other side. So you cancel out the factors that would cancel out there, or divide out, I guess I should say, really. So we've gotten rid of all the denominators. Now we just multiply, gather like terms, solve just like we have in the past. So this is 12 plus, this is 10z minus 20 equals 6z plus 12. So we'll gather all the like terms. Let's subtract 6z from both sides. That's going to be 4z over here. The 12s, see the two positive 12s, one on each side, they cancel out, right? Subtract a 12 here, subtract a 12 here, they're gone. And so then you're left with a negative 20. Let's take that to the other side and make it a positive 20. So there again, I'm assuming that you're at a level where we can do maybe a couple steps at a time here. Okay, again, if that blew you out of the water, then you're going to have to maybe show your work and move one term over at a time, okay? And just do that, that's no problem. But you probably are at a spot, hopefully, where you can start to speed things up a little bit without sacrificing any accuracy here. So 4z, again, I just need to divide by 4, and z equals 20 over 4 is 5. Now that appears to be the answer. Let's double check. What about any restrictions? So z cannot equal 2, negative 2, that's it, 2 or negative 2. So 5 is not 2 or negative 2, so there's a good chance this is going to work. And if you substituted 5 in, you'll see again in your textbook there that it does work. So your check here can be substituting z equals 5 into both sides, and we would get the same number. Okay, any questions about that? Okay, so here's a little checkup to see how you're doing with this lesson so far, if you're understanding this stuff. So I want you to solve this. Remember, I want you to tell me what the value or values of x are in this question. Show your work. Okay, if everyone could look up at the board here. I know some of you are done. Some of you are still working through this. Some of you had to start over. If you look at this here, so again, the factors that we have are x plus 2, x minus 3, and then this one here is actually x plus 2 times x minus 3, right? So these are the two factors. Those are the only two factors that we see in any of the denominators. So you have to multiply everything by this, okay? So in this case, the x plus 2 will cancel out, and you're just left with 3x times x minus 3. As we move through the other terms, okay, so the x minus 3 will divide with the x minus 3 over here. You have 5 times x plus 2. Make sure you remember this is a subtraction. So this is going to be negative 5x, negative 10 here. And then, of course, both of these will divide off with both of those, so you just have negative 25. Gather all the like terms, factor, let each factor equal 0 and solve. Now before you do this and say, hey, these are my two answers, you have to check each one. And this is where the restrictions come in handy. And if you note the restrictions, you'll see that negative 2 and positive 3 are not allowed. Positive 3 makes this denominator equal to 0. So that one you would have to reject. So this is your only answer, and yes, you could certainly check by putting that in to your equation and see if that's true, but that should be your answer. Okay? Any questions? So grade 11s, here's your assignments.